All right, let's get into it. We all use operating systems, every single day, but we almost never stop to think about what they're actually doing. We kind of see them as this boring, necessary bit of software humming along in the background. But what if I told you the OS is actually a brilliant magician, a master illusionist, pulling off these incredible tricks right under our noses?
I mean, really think about it. Right now, on whatever device you're using, you've probably got a browser open, maybe some music playing, notifications are popping up, all this stuff is happening in the background. But you only have one computer, one CPU, one chunk of memory. So how does that even work?
Well, the answer is it doesn't. Not really. Your operating system is creating a powerful, and I mean absolutely essential, illusion. It's tricking every application, and it's tricking you, into thinking the computer's resources are basically infinite and all yours.
So, just to make sure we're on the same page, what is an operating system? It's the software that manages, well, everything. All the hardware, all the other software, and its main job is to create this thing called a virtual machine. Basically, a fake version of your computer that's way more powerful and a whole lot easier to use than the raw hardware itself.
So how does it pull off this incredible magic show? Well, the secret, as laid out in this fantastic book, Operating Systems, 3 Easy Pieces, can really be broken down into 3 main ideas. 3 easy pieces.
So let's start with the first piece of this puzzle, virtualization. This is the OS's first, and you could argue its most important magic trick. It's all about creating the illusion that every single program has infinite resources all to itself.
And this brings us to what the book calls the crux of the problem. This is the big question we need to answer. How does the OS actually take a limited physical set of resources and make them seem limitless and totally private to every single app that's running? Okay, check this out. On the left, you've got the physical reality. You have one CPU, maybe a few cores, and one big pool of memory. But on the right, that's the illusion. Your web browser thinks it has its own private CPU. Your music player thinks it has its own private memory. Each one gets its own little virtual sandbox to play in.
So why is this so important? Well, this whole virtualization trick is what lets us run a bunch of programs at once without them stepping on each other's toes or crashing the whole system. It keeps them separate, it protects them, and it makes the whole experience stable. Without it, modern computing just wouldn't work.
So how does it do it? A huge part of the secret is right here in this tip from the book. Use time sharing. The OS is like a super fast dealer, slicing up CPU time into these tiny fractions of a second and handing them out to different programs, one after another. It happens so fast it feels like everything is running at the same time. And for memory? It uses space sharing, dividing up the physical memory into protected chunks so every program gets its own piece of the pie.
Now, that leads us directly into our second piece, concurrency. See, once you have all these different things happening at once, thanks to virtualization, the OS suddenly has a brand new problem. How do you manage all that chaos?
To get what I mean, let's look at a really simple example from the book. Imagine we have a counter and it starts at 0. Then we have 2 threads. You can just think of them as 2 little workers, and their job is to each add 1 to that counter, 100,000 times. Simple enough.
So, quick question for you. If one worker adds 100,000 times and the other worker adds 100,000 times, what should the final number be? The math seems pretty straightforward, right? It's got to be 200,000. But when you actually run the code, you get this, 137,298. And what's weirder, if you run it again, you'll get another random, but still totally wrong answer. Something is very, very broken here.
And I love this because this is a direct comment from the source code in the book. It just perfectly captures that feeling every programmer has had of, what is even going on? This isn't just a glitch, it's a deep, fundamental problem when you have things happening at the same time.
This crazy result is caused by something called a race condition. It's a type of bug where the final outcome completely depends on the random, unpredictable timing of events. It's like both of our workers tried to update the counter at the exact same time, and one of their updates got lost. So the OS has to step in and act like a traffic cop, providing tools like locks that make sure only one worker can touch the counter at a time.
Okay, that brings us to our final piece, persistence. Creating virtual resources is great. Taming the chaos of concurrency is crucial, but none of that really matters if all your work disappears the second you turn your computer off. This is the illusion of making data last forever. Here's the problem. Your computer's main memory, the RAM, is volatile.
It's super fast, which is great, but it needs constant electricity. The moment you pull the plug, poof, everything in it is gone, forever. Which is, a bit of a problem if you want to save a document. So here is our final crux of the problem. How does the operating system take all that fragile data from its temporary home in volatile memory and move it somewhere permanent, somewhere it will last, like on a hard drive or an SSD?
Well, the OS gives us this beautifully simple way to handle what is an incredibly complex task. To save a file, a program just makes a few simple requests. We call them system calls. It tells the OS to open a file, then to write some data to it, and finally to close it. That's it. Behind the scenes, the OS is doing 1,000 complicated things, talking to the disk drive, managing storage blocks, all hidden from view.
And this leads to another one of my favorite tips from the book. To make things faster, the OS is actually kind of lazy, in a good way. When your program says save this file, the OS says you got it, but it doesn't actually write it to the physical disk right away. It waits for a more convenient moment, maybe batching a bunch of small writes together to be more efficient. This productive laziness creates the illusion that saving is instant, making your whole system feel way more responsive.
So let's just quickly recap the 3 grand illusions the OS is pulling off. First, virtualization, giving every program the illusion that it has its own private computer. Second, concurrency, creating the illusion of order and control in what's actually a chaotic, multitasking world. And third, persistence, providing the incredibly powerful illusion of immortal data.
The authors of the book put this wonderful quote from W.B. Yeats in the preface, and it is just perfect for this. Understanding these deep ideas isn't just about filling your head with facts. It's about lighting a fire, about sparking a real curiosity for how these amazing systems we depend on actually work.
And that kind of leads to a final thought. The operating system is this master illusionist, right? It creates a stable, powerful virtual world on top of messy, limited hardware, all to make it usable for us. And it makes me wonder, what other essential illusions, maybe technical, maybe not, do we rely on every single day without ever even realizing it?